Right. Hello, everybody.
Hi, Alex.
How are we?
Good.
Thank you for coming. Okay, so today I'm going to talk about ES6 generators. And so, straight away from the title, does everyone know what ES6 is?
Nope.
No.
Spanish 6.
Okay. So, in a moment, so ES stands for EcmaScript. So, EcmaScript is a scripting language that JavaScript is based on. So, at the moment, all modern browsers, everything we write for, usually is to EcmaScript 5, and that's the standard we've been writing for.
How's it spelled?
ECMA
Ah.
script. And that's the standard we've been writing for years in JavaScript. I think the really old browsers like IE6 and i7 just support EcmaScript 3. So anyway, recently, or over the past couple of years, and we're really starting to use it now, is ES6. ES6 is exactly the same as ES5, but with some more new fancy special features. One of those features is generators that I'm going to talk about today. So, two main things I'm going to address today, and that is what are generators and how can they improve our asynchronous code. So, you can also use generators for other things, which I'll touch on later, but the main thing I'm going to focus on is how can we use it to improve our asynchronous code. So, first of all, what are generators? So, we all know what a function is, right? Same in any other language, it's a dead basic function. So when you invoke a function, what happens? It runs until you either hit a return statement or it gets to the end of the function. So generators introduce something new that we can do, and that is to pause a function. And that's really exciting, right? You can pause a function whenever you want to pause it. So, some new syntax. It looks similar to a normal function, but by the name, you've got a star, and that star just says, I'm a generator. And the other new syntax is the yield keyword. And the yield keyword says, when you get to me, pause, and then don't carry on until I've been told to carry on. Keep pressing the wrong button. So how do we use generators? So in this example, I'm going to show you exactly what happens. So when I say that a generator gets paused, it then continues when we call next. So here I've created a variable called myGenerator. And so when we invoke a function, the function runs. But the main difference to a generator is when we invoke a generator, we actually get an object instead. And on that object, we can call next. And so what happens is, so in this example here, I don't know if you can just see the grey, and that's what it returns. So we're creating a variable called myGenerator. We're invoking say hi and bye on that, which is a generator. So at this point, myGenerator is an object, which we can call next on. So what happens here is, when we call next on the generator, if you think, so imagine it starts here, we call next the first time, it gets to the yield, it yields hi, and then pauses. And what happens when we call next, we get an object again. That object's got two keys on it, value and done. The value is whatever the generator has yielded at that point, so in this case hi, and then the done value is the generator finished running yet. So first time we call next, we get hi, it pauses. Next time we call next, it says bye, and then the final time you call next, you get undefined and done true because the generator is finished running. So how do we communicate with generators? So again, a very similar example I gave you last time, but we're passing things into next. And what that means is in your generator, you can save values and you can assign variables. So in this example, I've got var first name and then var second name. I'm getting the generator object. I'm calling next. So if you can imagine, again, I'm calling next, so it pauses here. So this is the important part. Pauses here, yields first name. And the next time that I call next, you then pass in the value. So the first time I called next, I got a value of first name. And so I'm thinking, right, what do I want the first name to be? So the next time you call next, I'm assigning Alex into that. And then it yields second name after that. And then I pass in Perry. And then what happens is, after that, he gets logged out, Alex Perry.
So the value doesn't get changed. So where does where does Alex happen? What gets set to Alex?
So
Oh, I see.
Does that
Right,
make
okay.
sense?
Yeah, I get it
So
now. So first
var-
name and second
yeah.
name will contain,
so after you've passed in next here, var first name then equals Alex.
Right, yeah.
It'll get to here, pause, because you haven't called next again. You need to, every time you get to yield, it will pause until you call next again. And then it'll be called, and then you pass in Perry, and then it'll finish, and it'll just log out Alex Perry.
That was just a typo.
The missing assignment operator it's not supposed to be missing on the second line of the say full name.
Oh, sorry, yeah, it should be equals, yeah. My bad. Right, so that's generators in a nutshell, but you're probably now thinking, it's kind of cool, but what's the point, right? And the point is that in JavaScript, we love asynchronous code. We probably say asynchronous probably like 200 times a day. Everything we do is often asynchronous because we want the code to continue running. We want the user to ultimately be able to do whatever he wants to do while waiting for any request or for any asynchronous operation to finish. So this is where it gets a little bit complicated now. I'm going to try and talk to this really slowly. So this is how generators can make our asynchronous operations really nice. This is a really, really verbose example, so you can see what's going on. So first of all, focus on this bottom bit. Exactly the same as the last example I just showed you. So we've got var_gen, and we invoke the generator. So at that point, we've got a generator object, and then we call next. So we're telling the generator, right, start. So then we've got var_a, and it's going to pause here, and it will invoke get first name. And so if we look at get first name, I've just done a set timeout because that's an asynchronous operation. So if you can imagine then what get first name does, it calls gen.next once that set timeout's finished. So if you can imagine, this is really good because it pauses here, and then it will only carry on once gen.next has been called. And that makes sense, and that basically what this means is that you can write your asynchronous code in a synchronous way. Because as soon as you're writing code here, so var_b, you know that var_a is going to be available because gen.next has only been called once the set timeout is finished. So you got var_a is get first name, var_b is get second name, and then console log a and b, Alex Perry. Does that make sense? Any questions about that? I know that's pretty complicated. That took me a couple of times to get my head around.
So why are you only calling it when a thing times out?
So in JavaScript, something another example we do is asynchronous is we do requests. Okay, so you might have I don't know, var rates equals get the rates data from the rates API, for example. But what happens is usually is if you go to use that rates data straight after, so let's say on the next line, it's going to be undefined because rates hasn't returned the data yet. So what we usually do is we'll do asynchronous stuff in like a callback or something like that, so you know that it's available. But this is amazing because you can write as if it's synchronous code because at this point you know A is going to equal Alex.
The set timer is just simulating asynchronous.
It's just
Just a long line process.
Yeah, so you're just saying wait until.
Yeah, so that yields is saying, right, wait until I've got get first name. And hopefully this will make more sense as we go on. Right, so I'm going to take a step back away from that a little bit now and talk about how we used to handle asynchronous activity in Moonsick and in JavaScript in general. So callbacks, don't worry too much about that code, but I think the main when I first started doing Node and JavaScript in general, you write callbacks for your asynchronous code. So that's a function, usually passed into another function. It just gets run once when you've got that data. But you end up with this horrible nested structure because you've got to get this data, and then so say you want to do one thing, then you want to do something else, and once that's finished, you want to do something else, and once that's finished, you want to do something else. You end up with this horrible nested structure like this. And you end up with what we call in JavaScript callback hell, which is when you, like I said, you've just got functions inside functions inside functions, which is really, really difficult to read. It's hard to structure out. It just leads to nasty code in general. So what was our solution to that? Our solution to that was promises. You may or may not know about promises. I'm not going to go into them too much, but think of a promise as an object that represents a future value, and then we can access that future value by calling then on it. So that horrible nested code that we had before simplifies down to this. So I think in this case, I'm just reading a file and then .then, create a new directory, then .then to create another new directory. Promises are what we currently use in Moonstick. I think all the node platforms across the later rooms probably use promises at the moment. So it's really nice because you can just chain to their methods, so you can say, right, I want this to happen, then that to happen, and that to happen in that order. And it's all asynchronous. So what if we could combine generators and promises? So we could have all the advantages of promises and then the synchronous nature or the synchronous style of generators. So with the bits of code I've shown you at the moment, they're all like really simple, basic pieces of code. So I want to show you some real code as well. So this is real code from Moonstick. It actually serves the confirmation page. I've sudoed it a little bit, so we usually have some stuff in here which I've just commented out because that doesn't really matter. So what's going on here? So we've got data.booking, which is a promise. And then we've got the function, which has got confirmation result in it. So that's just a response from the confirmation API. And then once we've got that, we need to do some stuff on rec. So inside that, we're setting some things on rec. And then inside that, we're then calling the hotel details API, and then we're doing some stuff with that response. So I think that is pretty nice. It's fairly readable, but it'd be a nice example to see how we can use this in generators. So again, probably a bit overwhelming at first. So this is the exact same code as we had before, but using generators. So the first thing you'll notice is promise.coroutine at the top. I think that's how you pronounce it.
Not routine.
Coroutine?
Co-routine.
Co-routine.
Yeah, it's a co-routine.
Okay. And what that does, so this is I should mention this is also part of the Bluebird library. The Bluebird library is so again we use on Moonstick. Any other promise library will have something similar. And what that says is, every time you get to yield, wait until the promise returns until you carry on with the generator. So that's really nice again. So everything you've just seen before, I can write it in a synchronous way. I'd say it looks a lot clearer. So we've got var confirmation, which is a confirmation API response. No functions, no nesting, no anything like that. We're doing the same thing on rec that we were doing before. And then we've got var hotel details, is the hotel details response. And then what I'm doing now is I'm returning an object with all that information in. And then what promise.coroutine returns is a function that when invoked returns a promise. So I've got promise.coroutine, so here returns a function. I'm invoking that function, which returns a promise, and then I'm then calling then on it. So then it's just a normal promise at that point. And then whatever data is in the then will be whatever I've returned from the generator. I hope that makes sense. So another example, our new room availability code. Give you a quick overview of what's going on here. So again, I've sudoed it a little bit because it doesn't really matter, but we've got some condition. If that's false, we're going to make a call to the rates API. Once that's done, we're going to find the cheapest double. And once that's done, we're then going to group the rates and return that data. And we're also going to return the hotel details API response. So let's turn that into a generator. Again, dead simple. You can write it in a really synchronous way, which I think is a lot easier to read. So we've just got 4 variables just declared, one after the other. Rates, it's a rates response. Rates data about cheapest double. It's a rates data with cheapest double. We're going to then group the data together, and then we're going to get the hotel details response, and that's done. And then we're going to return that, and in our then, we can then do whatever we want with it. So this is something to point out, which is really nice, is that, again, it goes back to what I've said before, that the yield means that you know you've got that data. So for example, here, we're passing in rates to utils.find cheapest double. And usually you wouldn't have to do that, or it'd have to be wrapped in some sort of callback or some sort of something that checks to make sure you've got that data. But because I know, as soon as the code gets to this line, rates will be available, you can just pass it in as if rates was a string or a number or any other thing that you know is going to be there.
Presumably if you use the yield keyword and you haven't put the asterisk on the function header, then you'll get some kind of an error.
Yeah, it's just throw an error. So actually what I'm doing here is, so promise.coroutine accepts, so coroutine accepts a generator as its argument, so that's what I'm passing into it. It's just an anonymous generator.
Does that, sorry, I can't remember.
Yeah, it's fine.
That asterisk yield, is that effectively from a .NET point?
I'm not going to be able to.
Asynchronous word? Is that pretty much what that is? So that you need that asterisk in order to have a yield.
Yeah.
Yeah, it means
and that yield is just.
So the asterisk says this is a generator, and the yield is something that you can only use in generators.
Yeah. So it's async aware in a .NET.
Broadly, yeah.
Which is what we're getting in ES7. We'll start with that.
So here's another example, and this is actually from one of my personal projects. Don't worry too much about the code. Again, this is using promises, but it's really nested because everything's depending on everything else. So for instance, I've got ratings here and I need ratings down here. So even though I'm using promises, I still end up with it nested. Just highlighting here the three parts of that code that return a promise. So to turn this into a generator, I'm going to extract those parts of the code that return promises into methods. And then I end up with something really nice like that. So it's got ratings, is get ratings, images as images, for our profile picture, it's a profile picture, and return it.
Did you go back a slide?
Yeah.
Go back.
So do you lift that out pretty
So
much
I've
as is?
Yeah, literally as is.
Where does the yield go? It will go into those new functions?
Yeah. So all that the yield will do is invoke those functions. So, for example, the ratings yield that I had just invokes a function that returns this bit I've got highlighted in red. So that's a promise. And then the yield will wait until that promise is returned, and then everything else after that you can write synchronous. Go on.
So yield understands promises then?
Yes.
So if you pass yield a promise, it'll know.
So yield itself doesn't understand promises.
But it does when you use the
Promise. Coroutine understands promises.
Okay.
It's basically, so do you remember that very first example we did, that when we called next, when we've got the data, it's just doing that inside of it, yeah.
Just out of interest, that nesting doesn't make sense to me. So what you've wrapped up, so go for that first then, right?
Yeah.
Where you passing in the ratings. So you've wrapped up a call to images find all in its own function, right?
Yeah.
So that you can pass ratings in. So what I don't understand is why you've got the next then chained off the find all. Can you not just chain it off your other then when you're not nesting?
It needs the result from the function, isn't it?
You don't use ratings in the second promise though, so you could just do it. You could do a promise.all and do model.ratings.find all. And
so generators avoids all the promise.all stuff as well, because you can just write in a synchronous way. But
so I think what they're saying is, why is the second one nested? Because it doesn't actually rely on the result of the first one.
So
it doesn't need the result of the first one in order to.
It does. So
you need it is when you return the JSON.
Yeah. So I need it for when I return it.
Right. Okay. Yeah.
So I need to make sure I've got ratings, and then I need to make sure I've got images, and then I need both ratings and images to be returned in a response.
There are ways to restructure it so you don't have it.
Yeah, you can have
I was going to say
variables outside.
You don't even need to host the variables outside. You could just do models.rating.final and then model.images.final, put it in a promise all, and you get both values into the second, into the then, and then you have both of them, and then the next one's gone.
Yeah. But I'd still argue that the style of that is a hell of a lot simpler to read. than all the promises and nesting it like that, because you can just read it as if it's synchronous code.
And they're probably, presumably, even if it turns out you could have refactored the nesting out of that example, there probably are examples where you do need nesting.
Yeah,
definitely. So that's it, guys. So I hope I've sort of informed you about generators and shown you all the advantages there are from them. When can you use generators? So the latest version of Chrome, I believe, supports generators now. Node v4 came out the other day, which supports a lot, not just generators, but a lot of ES6 features. I'd definitely take a look at that.
Has IO been?
They've converged.
That's part of what v4 is. They folded IO back into it.
So a joint still involved?
No, it's broken started now.
Yeah.
Right, so they've yielded to...
Yeah, so IO was at version 3. So they decided to call it Node 4, so version 4. And then all that fails, you can use Babel. So if you want to use ES6 on your client side, use Babel. Babel's just a transpiler, which will transpile your code to ES5.
What was the previous version of Node before 4?
0.
0, 12,
then IO forked it, and they released version 1, then version 2, then version 3.
Yeah.
So they folded it back in, so they've gone, right, let's just call it 4. Because if you called it Node 1, it would be, hang on, is that the same as IO?
It's like the way we're on
it's just they've gone from 0.12 to 4, that's why.
It's semantic version.
They can do whatever they want.
It's almost 400 times better.
But they're doing like LTS releases and stuff now as well, like Linux.
Oh,
they're doing long-term support, which is really nice. So you get minimum 2 years support.
So they've got their act together a little bit.
Yeah.
That's what IO's forced.
I think someone slapped Joey down and said behave.
But yeah, so that's it, guys. I hope that all makes sense. I hope, and especially with the release of Node v4, I know Callum, his team have moved over to Node v4, so they can use all the ES6 stuff now. It's definitely something that we're going to do in Moonstick as well in the months coming. So I'm hoping that we can make use of generators.
So you touched on the browser stuff just briefly at the end then.
Yeah.
So what does Babel do? Is that actually good at doing what it?
Very, very, very good. Yeah, okay. It's very well supported. Almost everyone's using that now who wants to write ES6 stuff for client side.
Because that was the problem for ages, wasn't it?
Yeah.
There's all this new stuff.
Yeah, but you can't use it.
I've still got to support IE 7.
Yeah.
Yeah, you're never going to get IE7.
Yeah, so it doesn't go down that low. So it transpiles to ES5, which is like IE 8 up, I think. So what you have with Babel is you have a step. So Babel transpiles your code before you can release it. So you have like a build step.
Yeah.
And then creates a package which you can then release.
Cool. So if you do, for whatever reason, need to target a really ancient old browser, apart from killing yourself,
what can you do?
What do you do?
So I haven't looked into it massively, but you can have things like where you have Babel, and then on top of that you then have polyfills. But I think the answer is it gets messy when you start trying to.
The other way of looking at it is if they're on that older browser, they're used to things not working. So
just cry.
No, I know.
But no, it'd be really nice to get it server side when we've got Node v4. It'd be really good. Cool. Thank you very much for coming.
Thank you.